Hello and welcome to Mr. Tompkins EdTech and a brand new series of videos aimed at helping you prepare for your GCSE mathematics exams. In this series I'll be giving a complete walkthrough of the GCSE mathematics practice papers to help you prepare for your exams this summer. Now there are not so many of these and you don't want to squander them, so make sure you try the paper yourself first before you look at these solutions. This particular video is AQA November 2024, Paper 1, Higher Tier. Check the front cover of your paper to make sure it's the same one. If it's not, have a look through the playlist linked above, which includes all the GCSE Maths video walkthroughs I recorded so far. I'm busy recording all of the GCSE practice papers, so if the one you're looking for isn't there already, why not subscribe by clicking the big red button below and check back in a few days. Don't forget to click on the bell so that you'll get a notification when I upload the next paper. I'll put timestamps in the description below, so you can choose to watch the whole thing through, or you can click on the timestamp and jump to the particular question you need help with. If you have a question, check the comments below as someone else might have already asked the same thing. If it's a new question, leave it in the comments and I will try and answer all of them as soon as I can. Don't forget to mention which question on the paper you're referring to and try and be as specific as possible. Finally, if this video helps you with your revision, please give it a thumbs up. It will really help me out, and why not share the link with your friends because they might need a helping hand too. Okay, let's get into it. Question 1, work out the value of 1.5 squared. Okay, I think I'm just going to do this as a column multiplication. Just going to remove the decimal points to start with and just do 15 times 15. 5 times 5 is 25, so I'm going to write 5 carry 2. 1 5 is 5 plus 2 is 7. Add a 0. 5 1s is 5 and 1 1s is 1. So adding it up, I'm going to get a 5. A 2 and a 2, aren't I? Now if I've got 1.5 times 1.5, then I've got 2 digits appearing after the decimal point. So I'm going to have 2 digits appearing after the decimal point in my answer. It's going to be 2.25. Question 2a. Complete this number machine so that y equals 4x plus 5. Okay, so here's our input value x, which is here in the equation. Now what we want to do with the x is we want to multiply it by 4 and then we need to add 5. So in a function machine, that's the 2 steps we need to do then. We need to multiply by 4 and we have to add 5. Okay, so this is a times 4 plus 5 function. Part 2 says complete this number machine so that y equals 3x minus 24. Now at the moment they've put the 3 there, haven't they, at the end? When normally if I wanted to do y equals 3x minus 24, I'd have to do the same thing, wouldn't I? I'd have to times by 3 first and then subtract the 24. But seeing the minus 24 box is already occupied, I'm going to have to do it a slightly different way. I think what I can do here is I can just factorize the 3 out first. So if I bring the 3 out, I'm going to get 3 lots of x minus 3 goes into 24 8 times. Okay, so another way of thinking about it is to take your input value x, then subtract 8, and then finally multiply it by 3. So we've already got the multiplied by 3 there. So if I take 8 away first and then times it by 3, that's going to be the equivalent of what I just did. 2c says complete this number machine so that y is equal to x. Okay, so the input value needs to be the same as the output value. So if I've multiplied it by 6, at this point here I've got 6x. So if I want the output to be x again, so y is equal to x, I'm going to have to do the opposite of times it by 6. I'm going to have to divide by 6 here, aren't I? So if I put divide by 6 here, I'll go back to having x again. So my output value y will be the same as my input value x. Question 3. Each number in a list is increased by 10. Tick one box for each statement. The mode is increased by 10. Okay, so let's just think of some numbers. So if I had a list I don't know, 2, 3, 4, and I added 10 to each one of them, I'd get like 12, 13, 14. Okay. It's not very helpful because it doesn't have a mode. Let me just add a mode on the front. So if it was 2, 2, 3, 4, then I get 12, 12, 13, 14, wouldn't I? So yes, the mode has increased by 10 because the mode here is 2 and now the mode is 12. Okay, so yeah, the mode has increased by 10, so that is true. Is the median increased by 10? Well, the median is the middle one, isn't it? So if I take the middle one of this data set, it's going to be halfway between the 2 and the 3, which is going to be 2.5 for the median of that one, and halfway between 12 and 13 is 12.5. So it looks like the median of this one has gone from 2.5 to 12.5, so yes, it has increased by 10. Okay, what about the range? The range is the highest minus the lowest, so the range of the first set of numbers then is going to be the highest value minus the lowest value. It's going to be 2, whereas the range for the second set of numbers is going to be the highest 14 minus lowest 12. That's going to remain being 2. So will the range increase by 10? No, it won't. It will stay the same. 2, 2, range stays the same. Question 4a. Write the missing term in the geometric progression. Okay, so a geometric progression has a common ratio, which means that each number is the same multiple of the previous one. So if I look from there to there, I'm multiplying by 4, and from there to there, I'm multiplying by 4. So from here to here, I'm going to multiply by 4 as well. So 16 times 4, 16 doubled is 32, doubled again is 64. So that is 64 in there, and again, if I double 64, I'm going to get 128. If I double it again, I will get 256, so it seems to fit. Yeah, so 64. Part B says a Fibonacci type sequence begins with 5 and minus 9. The sequence continues by adding the 2 previous terms. Work out the next 2 terms. Okay, well, I'm going to get the next term by adding these 2 together. So 5 plus negative 9. That's going to give me negative 4 as the second term. Okay, and then the third term I'm going to get by multiplying, and the third term I'm going to get by adding these 2 numbers together. So what's negative 9 plus negative 4? That's going to give me negative 13. Okay, so yeah, they're my next 2 terms, negative 4 and negative 13. Question 5, here is a solid prism. How many faces does this prism have? Well, you can see it is a hexagonal prism. 1, 2, 3, 4, 5, 6 edges along that front face there. Okay, so in terms of the faces of this thing, it's going to have 6 faces going off in this direction along the sides, isn't there? So we're going to have these 6 times. We're going to have 6 of those. Okay, plus I'm going to have the front face here and the back face. That's another one, isn't it? So altogether I'm going to have 6 around the edge and 2 at the front and the back. So that is 6 plus 2, which is 8 faces. Okay. It's always going to be that for a prism. You're always going to get 2 more than the number of sides of the front face. Part B says the prism has a volume of 3,500 cubic centimeters and a length of 20. Work out the area of the cross section of the prism. Well, any prism, hexagonal ones or otherwise, are going to be the volume of them is going to be the cross sectional area times the length between the front and the back face. Okay, now here we want to find the area, don't we? We've been given the volume. So all we really need to do to find the area then, just dividing both sides by L, is use V over L, isn't it? So the volume of the prism divided by the length. So what is 3,500 divided by 20? Well, I'm going to scratch that 0 with that and divide 350 by 2 then. So half of 300 is 150 and half of 50 is 25. So I think that's 175, isn't it? So it's going to have 175 square centimeters as its area of its front face. Question 6, work out 1 1/5 minus 3/10. Give your answer as a fraction. Okay, so want to do fraction, addition, subtraction here. We need to have the numbers with the same denominator, and preferably as a top-heavy fraction rather than a mixed one. So this first fraction here, I'm going to first write as a top-heavy fraction, because 1 times 5 is 5 plus 1 is 6. So that's going to give me 6/5 minus 3/10. But next step, obviously, they need to have a common denominator. At the moment, I've got 5 and 10. So if I take this first fraction and I multiply top and bottom by 2, then I'm going to get 12 over 10 minus 3 over 10. Now I can go ahead and do the subtraction, can't I? So when I've got two numbers with the same denominator, I can just simply subtract the numerators from each other. So 12 take away 3 is going to be 9. So then that's going to give me 9/10, which is an answer as a fraction. So I think I'm good. Question 7. A large circle and a small circle are shown. The radius of the large circle is 12 centimeters, and the radius of the large circle to the radius of the small circle is in the ratio of 4 to 1. Work out the shaded area and give your answer in terms of pi. Okay, so we've got the radius of the large circle to the radius of the small circle in the ratio of 4 to 1. And we know that the radius of the large circle is 12. So what does that make the radius of the small circle? Well, 4 times 3 is 12. So if I times the opposite side by 3 as well, I should have 4 to 1 is the same as the ratio of 12 to 3. And therefore, the radius of this smaller circle is going to be 3. And the radius of my bigger circle is going to be 12, like that then. Okay, so then the shaded area is going to be the area of the large circle, take away the small circle. So the shaded area is going to be the area of the large circle, subtract the area of the small circle. Now the area of the large circle is just simply pi r squared, where r is equal to 12. So it's going to be pi lots of 12 squared, and then we're going to be minusing pi r squared for the smaller circle, which is going to be pi times 3 squared. Okay, so 12 squared is 144, so that's going to give me 144 pi minus 3 squared is 9, it's going to be minus 9 pi. So what's 144 pi take away 9 pi? Well, 144 take away 9 is just 135, isn't it? So that's 135 lots of pi. That's my final answer, 135 pi. Question 8a. In this part, assume that each person works at the same rate. So we've got 10 people and they can complete a job in 9 hours. If 15 people work on the same job, how many hours will it take to complete the job? Okay. Well, if there are 10 people taking 9 hours, then the total work hours is going to be the 10 people each doing 9 hours of work. Now that's a total of 90 work hours then, isn't it? Okay. Now if you want to do the same number of work hours with more people, then you just need to divide the total number of work hours by the number of people, and it should be the number of how much time it's going to take you then, isn't it? So then for 15 people, then the hours it's going to take is going to be the 90 work hours that it is divided by the 15 people who are going to be doing the work. So 15's into 90, I think that goes 6 times then, isn't it? So it's going to take them 6 hours. Just with these sorts of questions, easy to make a mistake. Just think, does it make sense? With more people, it's going to take less time, isn't it? So yeah, mine's gone down from taking 10 hours to taking 6 hours. It seems reasonable. Now part B says, in fact, of the 15 people, 6 work at a slower rate and 9 work at a faster rate. What does this mean about the number of hours it takes to complete the job? Tick one box. is greater than the answer to A, it's the same as the answer to A, it's less than the answer to A. Well, I don't think we can tell here because look, we've obviously got 9 working at a faster rate, which is more than the 6 working at a slower rate. But we don't know relatively how much faster they're going. You know, is the amount of work that those 9 people going to be doing going to be more than the amount of work that the 6 slower people aren't doing in the same time? We just don't know, do we? So at the moment, we don't know. So there was one more option at the bottom that was just hanging off the bottom of my page there, and that is it's not possible to say, and that is what I'm going to tick. It is just not possible because we don't know the relative speeds of those 15 people. Question 9, we've got some matrix addition here. So I've got A and 2 plus 1, 3B, and that's equal to 5, 20. So when you're adding matrices together, you add like with like. So you're going to add the top part with the top part to get the top part, and you're going to add the bottom part to the bottom part to get the bottom part there, like that. So we can actually form 2 equations from what we've got written down here. We can say that A plus 1 is equal to 5, and we can say that 2 plus 3B is equal to 20. Okay, so they're just 2 separate equations, aren't they? They're not simultaneous equations because they both contain a different variable. So we can just solve them both separately then. So I've got A plus 1 is 5. That's going to give me A is equal to 4 then, taking 1 away from both sides. And I've got 2 plus 3B is equal to 20. So subtracting 2 from both sides, I'm going to get 3B is equal to 18. And then dividing both sides by 3, I'm going to get B is equal to 6 for that one. So A is 4 and B is 6. Question 10, Clive owns 2 coffee shops, A and B. Out of 150 people, 18 people use both shops, 46% use shop A, 2/5 use shop B only. Complete the Venn diagram to represent this information. Now we're told here that the universal set is 150. That's quite useful. That means that altogether inside the box we're going to have a total of 150 things. And then, so what do we know from the information they give us? They tell us that 18 people use both shops. I like to start in the middle of a Venn diagram, and hopefully they tell us what that is. So there's 18 in the middle there. Now, 46% use shop A, so we need to know what 46% of 150 is, don't we? So what is 46% of 150? Well, 46% of 100 would be 46, and then therefore 46% of 50 would be half as much, wouldn't it? So 46% of 150 is going to be 46 plus half of 46. It's going to be 23 then, I guess. So that's a total of 69 people then. So 69 people use shop A, but remember we've already accounted for 18 of them because we've got 18 in that central section there. So if we take off 18, then that's going to leave me with, what, 51? So I need to have 51 in that section there, so altogether it gives me the 69. Okay, so we dealt with 18 people use both shops. We dealt with this bit, that gave us this bit here, that gave us the 51. And then what else we've got? 2/5 use shop B only. So 2/5 use shop B only. So what is 2/5 of 150? So 2/5 of 150. Well, 5s into 150 go how many times? Well, 10 would go in 15 times. So I guess 5 would go in twice as much. It's going to be 30 times. And then 2 times 30, that is 60. Now again, oh no, this one says that that's shop B only. So that means all of those 60 we can write in that side there. Okay. Now we're not quite done yet because we've still got this section down here to fill out. Now we do happen to know there are 150 altogether. So if we then take the other 3 away from 150, so 150 minus the other 3, what's that, 51 18 and 60. What's that add up to? So 150 minus 51 and 60, what's that? That's 111 plus 18, that's 129. Okay, so 150 minus 129, that is 21. Okay, so then that's the number then I'm going to put in outside both circles, and isn't it? It's 21 that goes here. Question 11. Construct the region that lies within 4 centimeters of the line. Okay, so for this one, you're going to need a ruler and a pair of compasses. So, and a diddy pencil, of course. Make sure your pencil tip and the tip of the compass are in the same place. And then we're going to have to set the compass aperture to 4 centimeters for this question. So I'm going to use the ruler for doing that. I'm going to put the one at the end of, like the tip of the pencil on 0 and the tip of the compass on 4. Need to get within the millimeter of this to get the marks. Right, now I need to construct 2 parallel lines either side of our initial line, and then 2 semicircles at either end. Now to do the parallel lines, I'm going to pick several points along the line and draw some little arcs like this. Kind of a series of them running the length of the line. So I think 3 places should be enough. And I'm going to do the same on the other side. So 3 little arcs. I'm going to use these to construct the parallel lines in a minute. Fiddly. Okay, I'll come back and do the lines themselves in a minute. While I've got the compass out, I'm just going to do the semicircles that we're going to get at either end. So there's one, and there's the other. So all the points along this semicircle are 4 centimeters away from the end of the line. And then the parallel line is going to be 4 centimeters away from the actual line itself. So then the region we want then is going to be all of those points inside the circle. So just to finish it off, I'm just going to draw the parallel lines. I'm going to push my ruler up against the arcs I drew earlier. And then with my pencil, I'm just going to draw a straight line from the ends of my semicircles along those bumps. And that should be my parallel line then. Just going to do the other one on the other side. Okay, and once that's done, you can see then that the locus of points is like a running track with 2 parallel lines and 2 semicircles. Question 12a, convert 27 over 11 to a recurring decimal. Okay, so we've got 27 over 11, want to write it as a recurring decimal. So we're just going to, I think we're just going to do it by short division. So So 11s into 2 don't go. 11s into 27 go twice, because 2 lots of 11 is 22. But then the remainder is 5 then, isn't it? So I'm going to have to add some zeros onto it, then attach these remainders to. So the remainder is 5. So then I can do, well, what's 11 into 50? Well, 4 11s is 44. So it goes in 4 times. Okay, but then the remainder is 6, isn't it? Because 44 plus 6 is 50. So I need an extra 0 to attach that remainder to. Okay, and we're going to go again. So 11's into 60. Well, 11 times 5 is 55. So I'm going to have a 5 there. But I've got a remainder now of 5. So I need another 0 so I can attach my remainder to. But you'll notice now I've got the same digit appearing here and here. So from this point onwards, we're just going to go around in a loop then, aren't we? So 11 goes into 5, 4 times remainder 6, and so on. So we're going to get the 60 appear in, and that's just going to give me this recurring decimal like this, 45454545. Okay, so to write that as a recurring decimal, I'm going to write 2 point and then 4 5 with a dot on the 4 and a dot on the 5, because it's this that's recurring over and over again, isn't it? Those two particular numbers. 12b, convert 0.15 with a dot on the top to a fraction. So this time we're going in the opposite direction. Now there's 1 digits replacing. So what I do here is I write the original one they give us and I equate it to x. So 0.155555 and so on is x. Then if I want to find 10x, that's going to be 1.555555 and so on. So then if I subtract one from the other, 10x take away x, that's going to give me 9x. And you can see all these 5's down here, look, they're going to cancel with all of those. So it leaves me with 1.5 take away 0.1, and that's going to give me 1.4 then, after I do that subtraction. So I get 9x is 1.4, so x is going to be 1.4 over 9, which isn't quite a fraction, is it, because I've got a decimal point in it. So I need to get rid of that decimal point. So multiplying top and bottom through by 10 to get rid of that decimal point, that's going to give me 14 over 90. But I can divide both of those by 2 again, can't I? So that's 7 over 45. 7 go into 45? Unfortunately, no. So I think that's about as far as I'm going to get then. It's 7/45. Question 13a. By rounding each number to one significant figure, estimate the value of the root of 401 plus 1.9 cubed divided by the cos of 58.7. Okay. So when you've got something like this and you have to estimate it, what we need to do is to round each number to one significant figure first. So this is going to be equivalent to, or almost equal to, well, 401 rounded to one significant figure. The first significant figure is that 4, isn't it? So rounding off after the 4, it's going to be 400 plus 1.9. The first significant figure is that 1 there. So rounding off after the 1, I'm going to round up, aren't I? So that's going to be 2. So root 400 plus 2 cubed, and then we're going to divide that by the cos of 58.7. Again, the first significant figure of that is that 5 there. So that's going to be equivalent to the cos of 58.7. That's going to round up. It's going to be 60 then, isn't it? Okay. Right, so what's that equal to then? So the square root of 400 I know is 20. 2 cubed I know is 8. Now, do I know what the cos of 60 is? Well, I do. Do you? You need to know your exact values, don't you? So you can either remember them as this big table, or I kind of remember them as a kind of more compact form. So what I do is I remember this big square root here and the numbers 0, 1, 2, 3, 4, which corresponds to the angles 0, 30, 45, 60, and 90. Therefore, the sine values and the cos values are the other way around. So you flip the numbers around, you've got 4, 3, 2, 1, 0, like that. Okay? So, and that's all over 2. So if I want the cos of 60, my 60-degree angle is here, my cos is here, so they meet there in the middle. Okay? So what's that then? Therefore, the cos of 60 then is going to be root 1 from that little 1 is under the square root, so it's root 1 all over 2, because we've got this 2 part at the bottom, so that's where that bit comes from. So the 1 part comes from the top and the over 2 comes from that bit at the bottom. Okay, now the root of 1 is just 1, so this is just the same thing as a half then, isn't it? So then what I'm doing is I'm dividing through by a half. Okay, well 20 plus 8 is 28, and dividing through by a half, that's the same as multiplying through by 2. So this is going to be the same as 28 times by 2, which is double 28. What's that? 50, 56? Okay, so it's going to be 56. Question 13b. Here is a triangle. I've got a triangle with sides 7, 5 and 3 and an angle marked x. Sam attempts to find the value of cos x using the cosine rule. Here is his working. He's got 5 squared equals 3 squared plus 7x plus 2 times 3 times 7 times the cos of x. Now, has he subbed that incorrectly? Now, it should start and end with the same letter. So if that's angle x, then this is side x over here, isn't it? So it needs to start with the 5, which it does. 5 squared equals 3 squared plus 7 squared. That's fine. This symbol here is wrong though, isn't it? There should be a minus there. Should be taking that away. The rest is fine. 2 times 3 times 7 times the cos of x. That's fine. So that symbol there is wrong. So in the first line, the first line should read 5 squared equals 3 squared plus 7 squared minus 2 times 3 times 7 times the cos of x. Okay? Yeah, so it should be a minus sign there in the middle. And then what happens after that? Because we need another criticism. Then what does he go on to do? He goes on to square... Oh, he's gone on to say that 3 squared plus 7 squared is 10 squared, which is not correct as well, isn't it? Okay. So, in the second line, he has combined 3 squared plus 7 squared into 10 squared. Should be 9 plus 49 equals 58. Think that will do? Question 14. Enlarge triangle PQR by a scale factor of -1/3, centre 0, 0. Okay. So a scale factor of a fractional thing is going to reduce the size of the shape rather than enlarge it. So we're going to end up with a shape that is smaller than the original one, and it's going to be a third as big along each dimension. The thing about the -1, though, when it's negative, it's going to be on the opposite side of the centre of enlargement than the object. So the image is going to be on one side of the centre of enlargement and the object is going to be on the other. So let's have a look at the distance from each of the points away from the centre. So this point up here, the point at P is 9 units directly above the centre of enlargement. Centre of enlargement, remember, was at 0, 0. So 9 units above. So a third of the distance in the opposite direction, that would be 3 units down rather than 9 units up. So the image of P, which I'm going to call P dash, is going to be down there. Okay. What about Q? Q is over here. Now that's 9 along and 9 up. So a third of that would be, rather than 9 to the right, it's going to be 3 to the left, and rather than 9 up, it's going to be 3 down. So the image of Q is going to be down here. That's Q dash. And then finally R. R is 9 units to the right and 3 up. So a third of that would be 3 units to the left and 1 down. So R dash is going to be there. Okay. So once I've finished making my shape like that, I can then join it together as one shape. So joining them up makes the triangle look like that. So you'll notice this one is 9, this one is 3. So you can see it is a third as big. It's also, so you've got the object up here, then the center in the middle and the image down here. And it's been inverted, so you can see that the shape is kind of upside down and flipped over. Okay, so that's all the properties you get from the negative symbol there. Look, that it's on the opposite side of the center and inverted. Question 15a, solve the inequality 20 minus 5x is less than or equal to 30. Now, as long as you keep everything positive, then you can just treat these the same way as equations. So I'm going to add 5x to both sides, basically to get rid of it being on the left and it reappearing on the right. So adding 5x to both sides, it's going to cancel from that side, leaving me with 20 on the left, and then I'm going to get 30 plus 5x on the right, like that. Next, I'm going to take 30 away from both sides. Okay, that will cancel, leave me with 5x on the right. On the left, I'm going to get 20, take away 30, which is minus 10. And then finally, dividing through by 5, I'm going to get x is greater than or equal to minus 2. So x is greater than or equal to minus 2. Just flipping it around like that at the end. And then part B says represent x is greater than minus 1 on the number line. So minus 1 is here, look. So I need to draw an open circle at x because minus 1 is not actually included in the desired inequality. It needs to be strictly greater than negative 1. So I also need an arrow going off to the right to indicate that I want the values to the right of that endpoint. Okay, so it should look something like that. Question 16, when w is truncated, the answer is 8. Sasha writes the error interval due to the truncation as 7.5 is less than or equal to w, which is less than 8.5. Give a reason why Sasha is wrong and state the correct error interval for w. Okay, well, notice that this word here is in bold because we've not rounded, we've truncated. Now, truncating is different from rounding. Truncating is basically keeping the whole number part and getting rid of the decimal. Okay, so 7.1 would truncate to 7, but also 7.8 would truncate to 7. You just kind of get rid of that number part on the end and leave yourself with the whole number part when you truncate. Okay, so if you think about the numbers then that truncate to the answer 8, they're going to be anything between 8 and 8.9999999, or just slightly less than 9, then, isn't it? So Sasha has described the error interval for rounding and not truncating should be that our w should be between 8 and 9, like that. Okay, so it can be equal to 8, but it can't be equal to 9 because 9 obviously truncates to 9. But everything is slightly less than 9 will truncate down to 8. So the correct error interval is 8 and 9, like that. 17a, a circle has center 0, 0 and circumference 36 pi. Work out the equation of the circle. Okay, well, we know that we know two formulas for circles: cherry pie delicious and apple pies are 2. So here we've been given the circumference. Circumference is pi times the diameter, or another way of saying that is pi times 2 lots of the radius, or 2 pi r. I think I might use that version here because I need the radius for the equation of the circle. So I'm going to use c equals 2 pi r, or pi d, and I know that c is 36 pi, so 36 pi is equal to 2 lots of pi r. So cancelling the pi's, I've got 2r is 36, so in other words, r is going to be equal to 36 divided by 2 is going to be 18. Okay, so the radius of my circle is 18. So if the radius is 18, then the equation of the circle is going to be of the form x squared plus y squared equals r squared. So it's going to be 18 squared. Okay, so equations of circles are always the form x squared plus y squared equals r squared, where r is your radius. Yeah, so that's why you just substitute in r18 for r, where the r is there, to get that one. Okay. Part B says point J has coordinates 15, 0 and point K has coordinates 30, minus 5. work out the equation of the straight line through J and K. Okay. So the first thing we need to do is work out the gradient. Now there is a handy formula for doing it, which I tend to use. I've got my gradient is equal to y2 minus y1 over x2 minus x1. So it's just a formula that you can remember. So x1 and y1 are your coordinates from... So it was a bit off the top of the screen there. Let me just put it down a little bit. So x1 and y1 are our coordinates from the first point, and x2, y2 are our coordinates from the second point. So we need to sub those carefully into our equation now and find the value of m. So y2 is this value here. That goes at the start. So I'm going to have minus 5, and I'm going to take away y1, which is the first y coordinate. So I'm going to take away 0. Goes there. And then on the bottom, I've got x2, which is 30, so I need to put it in that position. So the 30 goes here, and then I'm going to take away the x1 value. x1 is 15, so I'm going to be taking away 15. Okay, now I've carefully subbed that in. I can just work it out. Negative 5 take away 0, well, that's just negative 5. 30 take away 15, that's 15. So I've got negative 5 over 15, dividing top and bottom by 5. That's the same thing as minus 1/3 then, isn't it? Okay, so the gradient of my line is minus 1/3. That means the equation of the line is of the form y is equal to minus 1/3 of x plus c. Okay, because every equation of a straight line should be in the form y equals mx plus c. And we just found what m is, didn't we? We found that m is minus 1/3 there, look. Okay, so that's why I've written it in there. So I've got y equals minus 1/3 x plus c. So to complete the equation of the line, I just need then the c part. And I can do that by taking one of the equations that lie on the line and subbing its coordinates in and seeing what's left. So I know then that the line passes through the coordinate 15, 0. Okay, so subbing in x is 15, y is equal to 0 into our partial equation, I'm going to get 0 equals minus 1/3 of 15 plus our value of c. Okay, so what is minus 1/3 of 15? Well, 15 divided by 3 is 5. So it's going to be 0 equals minus 5 plus c. Taking the minus 5 to the other side, I'm going to get c is equal to 5 then, aren't I? Okay, so if c is equal to 5, then the equation of the line is going to be y is equal to minus 1/3 of x plus 5 then. Okay, that's the equation. Question 18a. Express x squared plus 8x minus 5 in the form x plus a all squared minus b. Now that's what we call the completed square form, isn't it? So we need to complete the square on this quadratic equation. Okay, so when we complete the square, you need to look at that middle term there, the coefficient of that middle term. That's 8, so we need to halve it, and then that's what's going to appear in the bracket. I'm going to get x plus half of the 8, which is 4, all squared. Okay, that's what we're replacing those first two terms with, but x plus 4 all squared is actually x squared plus 8x plus 16 if you multiply it out. So we need to take that extra 16 off that we've just introduced. Okay, and then combining that minus 16 with a minus 5, I'm going to get x plus 4 all squared minus 21. So yeah, that's the completed square form of this equation, or this quadratic, sorry. So x plus 4 all squared minus 21 is my answer. Part B says a curve has equation x minus 7 all squared plus 8. Write down the coordinates of the turning point of the curve. So this is already in completed square form. And so in order to find the turning point on the curve, the lowest point on the curve, now this equation, the lowest value you can get is when this part of the bracket here is 0. And the reason for that is when you square a number, it's always positive. So the smallest value a square can be is if you're squaring 0, because that gives you 0. Everything else is going to give you a positive number, which is more than 0. So the value of x that makes that bracket 0 is x is equal to 7, isn't it? Okay, because 7 minus 7 is 0, 0 squared is 0. So if you've got 0 squared is 0 and you plus 8, then y then is going to be equal to the number on the end. So that number on the end then is going to be our value of 8, and x is going to be 7. So you can find 7 from the bracket. It's the value of x that makes the bracket 0, and the y1 then is the number left on the outside. So it's going to be 7, 8 as the coordinates of that lowest point. Question 19a. Expand and simplify fully x plus 2 times 2x plus 3 times 3x plus 4. Okay, so I've got triple brackets here. We're going to multiply them out at double bracket at a time. So we're going to do this bit first. So using FOIL, or first, outside, inside, last on this one, or whichever way you do it, I'm going to multiply those 4 things together. So what's that going to give us? I'm going to leave the x plus 2 alone for now. I'm going to come back for that in a minute. And then multiplying out that bracket there, and I've got 2x times 3x to start with. That is 6x squared. And then I've got 2x times 4. That's going to give me 8x. And I've got 3 times 3x, which is 9x. And I've got 3 times 4, which is 12. Okay? I think I'm just going to combine those 2 middle terms together first, because I've got 8x and 9x that I can combine together into, what's that, 17x? Okay? Now once I've done that, I need to multiply everything in the second bracket with everything in the first bracket. So I'm going to have to multiply the x with the 6x squared, the 17x, and the 12 first. So just going to write that down first. So x times 6x squared, that's 6x cubed. X times 17x, that's 17x squared. And x times 12, that is 12x. Okay? Then once I've done that, I'm going to multiply everything in the bracket by the 2. Okay? And then we'll look to combine them in a sec. I'm just going to come down the line and along a little bit, because it's kind of handy if I draw them or write them down underneath the similar terms. So if I do 2 times 6x squared, it's going to give me 12x squared. So just as a top tip, if you kind of come down and write it here, then you've kind of aligned it, and then it makes it easy to add them all up again in a second. And then the next term, 2 times 17x, that's 34x. You can see I've aligned that underneath the x as well. And then 2 times 12 is 24. Okay, so like I say, the reason I was doing that is then you can just kind of column add these up now. So in the first column, I've just got 6x cubed, and in the second column I've got 17x and 12x, which adds up to 29x squared. And in my next column along, I've got 12x and 34x, which is going to give me 46x. And then finally, I've just got that 24 on the end, which is just going to give me my last term of 24. Okay, that's the solution. Then 6x cubed plus 29x squared plus 46x plus 24. Now in part B, it says use your answer to part A to work out what 102 times 203 times 304 is. Okay, now what we worked out in the first part was x plus 2 times 2x plus 3 times 3x plus 4 was that long thing there, 6x cubed plus 29x squared plus 46x plus 24. So presumably we can use this to match up and work out the answer. So it doesn't just want us to multiply them together, it wants us to use this answer to do it. Now if you have a compare the parts, I've got like this part goes with this. So x plus 2 is 102. So x there then must be 100 then, mustn't it? Because 100 plus 2 is 102. And that kind of makes sense with the other bits as well, because the next bit is going to be 2x plus 3, 2 lots of 100, 203, 3 lots of 100, 304. Okay, so if x is 100, then that is going to give us x plus 2, 2x plus 3, 3x plus 4, then it's going to match up with what we got there. So then presumably, if I then sub in x is equal to 100 into these other bits, it should give me the answer. So I'm going to get 6 lots of 100 cubed plus 29 lots of 100 squared plus 46 lots of 100 plus 24. Okay, so what is 100 cubed? Well, 100 cubed is going to be, well, it's going to be a million, isn't it? 100 times 100 times 100 is a million. So that's going to give me 6 million plus 100 squared. 100 squared is what, 10,000. So that's going to give me times 29. That's going to give me 29,000. Is that another zero? No, it's an extra zero, isn't it? It's 290,000, that one. And then 46 times 100 is going to be 4600, and then I've got the 24. Now, luckily, they all kind of add neatly together, don't they? Might have been easier if I could stack them. So rather than write them like this, if I could kind of written them underneath each other. Might have been easy to do this last little bit. Maybe do it like that. So if I add them up like that, so I've got the 24 at the end, and then I've got the 46, and then I've got the 29, and then I've got the 6. So it comes to 6,294,624. Question 20, part A. Show that the root of 363 divided by the root of 3 simplifies to an integer. Okay, well, if I've got a root divided by a root, I can put those under one big root, then can't I? I can say that's the same thing as 363 divided by 3, all under that square root. How many times does 3 go into 363? So 3's into 3, 6, 3 goes 1, 2, 1 times. So that's equal to the root of 121, and the square root of 121, that's just 11, isn't it? Well, I guess it's plus or minus 11. But yeah, it simplifies to an integer. So 11 is an integer, isn't it? Part B says rationalize the denominator and simplify this one. So if I've got a denominator that is a rational number, if I just times top and bottom, times them through by root 5 over root 5. Now root 5 over root 5 is just 1, isn't it? Anything divided by itself is 1. So I wouldn't be changing its value if I did this. Would, however, change what it looks like, because root 5 times root 5 is just 5 on the bottom, and I'm going to get 20 root 5 on the top, because 20 times root 5 is 20 root 5. And then I can divide that 5 into the 20, which is going to give me 4 then, isn't it? So the final answer then is going to be 4 root 5 in its simplified, rationalized form. Question 21. Here is a sketch of the graph y equals tan x, where x lies between 0 and 360. So we can see like half of one of the curves, a complete one, and another half for the period from 0 to 360. Now we're given that tan of 78.69 is equal to 5. Work out the other values of x, where tan x equals 5. Okay. So reading across from 5, you can see it hits the curve in 1, 2 places down here. Now we know that this one down here, apparently that's the 78.69 one. So if we want the other one, it's going to be like one period of tan's difference between there and there, which is 180 degrees. It repeats every 180 degrees, isn't it, tan? So if I take 180 and I add on 78.69, what do I get? That's going to be a 9, 6, 8, 5. So 258.69 then, adding that on. So that's going to be 258.69 for that. Okay, and then it says work out the two values of x where tan x is minus 5. Okay, so where's minus 5? So minus 5 is going to be like here and here. Now, if you think about it, the minus 5 one, the distance back from 90 to 78.69 is going to be the same as the distance from 90 up to my distance my next value there for the tan of minus 5. So if I work out the difference between 90 and 78.69 first, so what is 90 minus 78.69? Sometimes it's easier to add on, so what do I need to add on to 78.69 to get 90? Well, I need to add on, what's that, 11.31? Would that work? Yeah, that's going to take me up to 90, isn't it? Okay, so now I know the distance from 90 down to 78.69 is 11.31. Then the solution I want for negative 5 is going to be 11.31 beyond 90. So if I do 90 plus 11.31, that's going to give me my first solution, which is, what's that, 1, 3, 1, 10. So that's 101.31 is my first solution, 101.31. And then my second solution I'm going to get by adding a further 180 on top of that then, aren't I? So add in another 180 to this. That's going to give me 131.82. So that's 281.31. 281.31. So my two solutions are 101.31 degrees and 281.31 degrees. Okay. Question 2, I'm given that 7 to the power of n is equal to x. Match each expression on the left to the correct expression on the right. One's been done for you. So 7 to the minus n will be 1 over x. That makes sense. 7 to the 2n, that's going to be, well, isn't that going to be 7? Isn't that going to be x squared? Because if you've got 7 to the power of n and you square it, that's going to give you 7 to the 2n then, isn't it? So yeah, that works. So that's going to go with x squared. 7 to the n plus 1. Well, I'd have to take 7 to the n and times it by 7 then. So, and that's x. So that's going to give me 7x. So that one needs to go with 7x. And then finally 7 to the half n. That's going to be 7n to the power of a half. In other words, it's going to be x to the power of half, which in other words is going to be the root of x then, that one. So that one is going to be the root of x. It's going to go with that one. Question 23. In each part, the graph shown is the transformation of the graph y equals x squared. Write down the equation of the graph shown. Okay. So here, the graph is y equals x squared is going to be like this graph here, isn't it? And what's happened to my graph is that every point on the graph is moved up 2 places. I actually drew this one quite poorly. It should actually go through 1, 1, shouldn't it? The quadratic curve, y equals x squared. So like this point here has gone up 2 as well, and every other point is as well. So you add in 2 to it to go upwards. So it's a translation of 2 units up. So our graph y is equal to x squared is going to then go to y is equal to x squared plus 2. Okay, so then that's y equals x squared plus 2. I don't know if that's hanging off the edge. Let's just move it over a little bit. Yeah, so it should be y is equal to x squared plus 2. 2 units up. Part B, I've got the original curve reflected then in the x-axis. So reflecting in the x-axis, that is y equals f of x goes to y is equal to minus f of x. So we need to stick a minus sign in front of it. So our y is equal to x squared is going to become y is equal to minus x squared. Okay, so that one is y equals minus x squared. And then part C, my original graph would look like this, isn't it? It's going to be that. And what's happened to this graph? You can see it's shifted to the right, isn't it? So this point here has ended up going over here. It's moving to the right 3 units, as is this point here. Look, let's move 3 over to there. So adding 3 to the x coordinate. So it's a translation of 3 units in the direction of x. So a shift like that, y equals f of x would be going to y is equal to f of x minus however many units to the right you go. In this case it's 3. Okay, so for our equation, y is equal to x squared, that's going to go to y is equal to x minus 3 squared, like that. Okay, so that's our graph there, y equals x minus 3 squared.
Mr. T, he's the best.